Hello, this is Hui. Welcome to watch my video, C++ programming on Linux. In this short video, it will discuss concepts and basics of Bufferevent, another topic of using Libevent libraries. Bufferevent consists of an underlying transport like a socket. Every Bufferevent has an input buffer and an output buffer. These are type of structure EV buffers. When you have data to write on a Bufferevent, you add it to the output buffer. When a Bufferevent has data for you to read, you draw it from the input buffers. Every Bufferevent has two data-related callbacks, a read callback and a write callback. By default, the read callback is called whenever any data is read from underlying transport, and the write callback is called whenever enough data from the output buffer is emptied to the underlying transport. You can overwrite the behavior of these functions by adjusting the read and write watermark of the Bufferevent. The example of this video, it will write a TCP equals server C++ program using Libevent Bufferevent concept, and then upgrade it to SSL TLS equals server. Here on our Linux, we create a program bev tcp equals server.cpp. Same as previous video's example, the usage will take one argument from command line power number. To create a TCP equals server using Bufferevent, step 1, get power number and parse listening address. Step 2, create event base. Step 3, allocate a new event connection listener object to listen for incoming TCP connections on a given address and trigger the accept callback. And step 4 will set accept error callback in case accept failed, and then dispatch event loop. After that, adjust callback functions. It will be read callback, accept callback, event callback, or write callbacks. So step 1, get the power number and parse listening address. Power number from argument 1, and we declare the address object, assign the address of server. So now we have a power number and parse the incoming listening address. Step 2, create event base. If create event base failed, print out the error message and exit with the exit code -1. Step 3, allocate a new event connection listener object to listen for incoming TCP connections on a given address. Callback function will be the accept callback. Function will be EV connection listener new binding. This function allocate a new EV listener object to listen for incoming TCP connection on a given address. This function takes 7 parameters. First parameter is the base. Second parameter is a callback function. Third parameter is the pointer of parameter given to the callback function. Next parameter is LEV option flags backlog passed to the listener address of connection and the socket address length. Back to our program, we create connection listener object. We name it listener equal first parameter event base. Second parameter is accept callback function. Third parameter will be the parameter passed to this callback, which we don't have right now. Next is LEV options. For listener, we can have all these kind of options. In this program, we just use very simple LEV option close on free, LEV option close on exec, and LEV option on reusable. Next is backlog, -1 by default, address length. If not a listener, it means create a listening object field. We just print out error message. During create a listener object, it will set accept callback function. Now we need to set up callback error functions. We name it accept error CB. Print out the message. Our server is start listening on the port number. Next step, dispatch event loop. Before exit, disable and deallocate the connection listener object. Free the event base allocated memories. We fix this typing error and finish our main program. We'll start to write our callback functions. First, accept callback. This function accept listener and create a socket-based buffer event. Set buffer event callback, read callback, write callback, and event callback. And then we enable buffer event read and write. First, get event base from listener object. And we create socket-based buffer event. BEV. First parameter will be the base. Second parameter is the FD from this function. The third parameter will be the option. BEV option close on free, BEV option read safe, BEV option default callback, and BEV option unlock callbacks. In this demo, we just use two very popular options, BEV close on free and BEV option default callbacks. Next, set the buffer event callback functions. First is the buffer event, BEV. Second parameter is the read callback, read CB. Third parameter is the write callback. In this demo, we read write in the same callback function, so we don't use write callback. Next is the event callback, event CB, and the next parameter will be the parameter passed to these callback functions. In this demo, we just use none. and enable the buffer event for read and write. Now we finish our accept callback. Next, we are going to adjust accept error callback. In this function, we'll just get error code and print error message, exit event base loop. First, get the event base. Second, we get the error code. Now we will print out the error message. And then exit from event base loop. Now we finish adjust accept error callback. Next, we are going to write an event callback. Each event has an event code, and this event code will be as a second parameter of event callback, name is event. Buffer event has defined event code bev event connected, bev event EOF, bev event error, bev event reading, event timeout, and event writing. In this demo, since we don't have event logic, so we just print out which event we have been received. First, we print event CB invoked. In order to save time, we just write 3 events. So we just print out which event have triggered. For the EOF and the error, we have to deallocate the memory, our buffer event. Now we finished at just the event callback. Next, we are going to write read callback. Function read callback, read from the buffer and the eCallback. Each buffer event has an input buffer and output buffers. We read from input buffer, and to write, just move the date to the output buffer. SRC, which is the input buffer. DST is output buffer. To echo back input to the output, we are just using one simple function. We finish all our callback functions. Now we save our program. We compile our program. Our program has been compiled. Executable bev TCP equals server. To test our example, we're using 2 Linux server. On the top terminal, which is a Ubuntu Linux server, IP address 10.0.0.191. We just edited and compiled our bev TCP equals server executable. Bottom is Debian Linux IP address 10.0.0.124. We have a previous video example, basic TCP client, top terminal. We start our server, port number 1234. Now our bev TCP equals server starting listening on port number 1234. Bottom, we start our basic TCP client connect to the server 10.0.191, port number 1234. We have connected our server, accept connection. Now we start send a message. This is Hui test BV TCP equals server, message number 1. So you can see we send a message to the server 46 byte and we received 46 byte. This is the message echo back from the server. Message 2. So we send a 69 message, replies back 69 character. This is the Hui test send a second message to BV TCP equals server, message 2. Now we quit and our server received BV event EOF. Back to our Ubuntu Linux, we create a new program BV TLS equals server.cpp and we copy from BV TCP equals server.cpp. R BV TCP equals server.cpp. Upgrade TCP equals server to TLS equals server. We have to add 2 arguments from command line. First argument is a certificate. Second argument is a private key. Bufferevent can use OpenSSL library to implement the SSL TLS secure transport layer. You can create 2 kinds of SSL bufferevent, a filter-based bufferevent that communicate over another underlying bufferevent, or a socket-based bufferevent that tell OpenSSL to communicate with the network directly over. So 2 functions will be bufferevent OpenSSL filter new and bufferevent OpenSSL socket new. In this example, we try to use bufferevent OpenSSL socket new to connect network directly over. So after get the port number from argument 1, we instantialize OpenSSL context. TLS server method. Field create SSL context. We just print out a message and exit. Next will be apply certificate. The certificate from argument 2. File type is PM. If error, we just print out message and exit. Next, set using private key file. First parameter cdx. Second parameter is a private key file from argument 3. File type is PM. If error, we print out a message and exit. Next, there will be no change of create listening and listening accept callback, and there's no change set error callback dispatch event base, and we need to clean the memory allocated for the CTX. Now we go to our accept callback function. In the accept callback function, for the TCP, we use bufferevent socket new to create bufferevent. Using OpenSSL, we need another function, bufferevent OpenSSL socket new. First parameter is the base Second parameter is FD. Third parameter will be the SSL. Before we do that, we need to pass the parameter CTX. Third parameter CTX. Next parameter, event on the SSL accepting. Next is the buffer event option, close on free, and the option default callbacks. Finish update, accept callback. Our buffer event will be the directory using OpenSSL on the socket. Read callback and the event callback will no change. When we set our parameter path to accept callback, CTX. Now we finish update our program from the TCP echo server to TLS echo server. We save our program. We compile our program. BEV TLS echo server. Now program has been compiled. Our executable BEV TLS echo server. To test our TLS echo server, we using same two Linux server. On the top is a Ubuntu Linux server, IP address 10.0.0.191, which we have just compiled. TLS echo server executable. We're using the same certificate and the private key from previous videos, and on the bottom is Debian Linux IP address 10.0.0.124, and we're using OpenSS TLS client, which from previous videos example. We start our server, our number 1234, certificate, private key. Server started listening port number 1234. On the bottom, we start our client, host 10.0.0.191 port number. Now we have connected our server, accepted, buffer event connected. We send a message. Server sends 46 byte and we received 36 byte. This is Hui test BEV TLS echo server message 1. Second, we send a message 58 byte. We received 58 byte. This is Hui test TLS BEV echo server message 2. Second time. If we quit. Hello, thanks for watching my video, C++ programming on Linux. Wish it is useful and enjoyable. It's great to have your feedback.